So this is what we have covered in the last lecture. So we saw a one calculation end to end understand the to understand the training process of my artificial neural network. And today we will discuss about first points about the some terminology about this deep learning that we use in the training process. And before that, we will also discuss about the activation functions. So if I talk about a neuron, so now I'm talking about the activation function. Talking about the activation function. So remember, in the last lecture, I was using the activation function 1 by 1 plus e to power minus x. I said that this is the activation function, and all my calculation that weight and bias we are passing to the activation function. So we were discussing about the activation function. So in the last lecture we discussed about the activation function that is the sigmoid, and one is the 1 by 1 plus e to power minus x. So today, first we will discuss about the what is the need of the activation function. So if I just simply use the output as a, if I simply use the, if I, this is my neuron which contain the, input like x1, x2, x3 with the value of w1, w2, and w3. If I simply use the output as a linear line, which will be the w1 x1 plus w2 x2 plus w3 x3 plus bias. If I use the single line, so you also have seen that your straight line is not a good separator. Your straight line is not a good separator when your data is more complex. For example, your data looks like this one. This is the one class, and this is the another class. So you have seen that if I use a single this separator, lot of misclassification will be there. So instead of doing this line as a separator, what we are doing is I am just creating a model like these things. Right? If you remember these things, you already have seen in the logistic regression. Can you please confirm these things? This kind of a scene that you already have seen in the logistic regression. So the purpose of the activation function is, purpose of activation function is to increase the non-linearity in the model, to increase non-linearity. In model. This is the purpose of your activation function. Now, what's the meaning of non-linearity? You can see that when I'm using the sigmoid, my line will become this one, and when I'm using the multiple sigmoid, so definitely it will increase the complexity in my model. So if my model is very simple, so definitely still it is not a good model. My model should be not too much simple and not too much complex. Okay. And now we will discuss the different type of activation functions that we have. So my first type is my first activation function, which is quite popular. That activation function is my ReLU. We call these things function name is ReLU, or the name is the rectilinear unit. So we call it as a ReLU. This function says x greater than equal to 0 if the value is x greater than equal to 0, my y will become 0, and for x greater than 0, it will become y as it is. For x greater than 0, it will become y is equal to x. And if I plot the graph will be looks like this way. For the negative value of x, it will be 0. And for the positive value of x, it will be this way. This is my ReLU base. So now if you see these things, in this ReLU, there is a one problem. So like for example, I am passing some information. Here I have the 5, 1, 2. This is the x1, x2, x3. And then after that, we have the weight associated is, for example, -10, 5, and 1. And bias is 2. If I perform this calculation, it will be 5 into -10, 5 into -10, plus 1 into 5, plus 2 into 1, plus 2. It will be -50 plus 5 plus 2 plus 2. If I do these things, 7 plus 9, 50, -15 plus 9, it will be -41. And if I pass these things to my ReLU function, what will be the output? Can you please tell me, guys, what will be the output if I pass these things to my ReLU? Tell me, guys, what will be the value if I pass to my ReLU?
Yep. Yes, 0.
Aisha is mentioning 9. No, guys, this is a 0, right? You have seen that x less than equal to 0 is 0. Any doubt here?
No,
No.
I got only the 3 responses. Guys, it's pretty simple, right? If you see these things, x
ReLU basically negative value, it will convert into neutral.
0.
Yeah, 0.
Negative values always be the 0. Okay. So output will be the 0. Output will be the 0. Now, in this scenario, output will be the 0. Correct? In this neuron gives me the output as a 0. And now when it is giving me the output as a 0, this output will again become the input for the next neuron. And when this output is 0, when I further do these calculations, again it makes the next thing again 0. Yes or no?
Yep.
Right? So if I just perform these things, if I just use this output as a 0, again this output will be treated as an input, And again, when the input will be 0 and 0 into any weight will again 0. So there is a one limitation of the ReLU. There is a one limitation of ReLU. Limitation is for the negative value, for negative values. I will share this PPT as well, guys. But apart from the PPT, I just explain this way also. So I will have the PPT as well. So I will share with you also. So limitation of the ReLU is for the negative value, output will be 0. That generate dead neuron. We call this problem as a dead neuron.
Yeah, but Harish, this will only be possible if it is super high, correct? If one of the negative value is super high and cannot be balanced by other inputs.
No. If you see these things, any negative value.
No, but then if this negative value was say 2 and then weight was -1, then we would have got a positive value, no?
See, all this, the thing is, all this answer, all this calculation of W1 X1 plus W2 X2, what is my resultant value? That value should be positive.
Yeah, correct. See, what I'm trying to say is because we had a very large weight, large negative weight, the result, the the summary result was 0. But if this weight was -1, correct? Say instead of -10, and then the input was only 1, then we would have got a positive value.
Correct.
So what we are saying is only if after we summarize all the weights, if it is negative, then we will have this problem.
Correct. This is what
Not
I'm
the
saying.
input value. Okay,
No,
not
no,
then.
no.
Okay.
After
I thought that.
doing this calculation, right? After doing this calculation, what is my resultant output? If it is negative, then 0.
Yeah, okay. Thank you.
Okay. So we call this problem as a dead neuron. So what should be the solution? Because this ReLU is a very useful, activation function, and we mostly use the ReLU. So here, the solution of this dead neuron is your leaky ReLU. So solution for this problem is the leaky ReLU, and leaky ReLU says for x less than equal to 0, or you can say that for the negative value of x, y will be alpha x. They are putting some value of alpha, and it will be y is equal to alpha x. And for x greater than 0, y will be x. So graph for the negative value, it will be yx. This will be like this one. And for the positive x, it will be the state. So this is the only use, or the only all the things will remain the same. The only purpose is that the use of the leaky ReLU is to avoid the use of the leaky ReLU is to avoid the dead neurons. Okay, it used to avoid generation of dead neurons. Now this is the 2. If you talk about the next one you already have seen, that is the sigmoid function. So can anybody tell me the sigmoid function?
One by one C for minus X.
Okay. Can you explain these things? Let me just take. Okay, yes, mention these things. That is good. And let me take, apart from the Yash, Adamme, what is your thought on this one? Any idea? Aisha, any idea? Tell me, guys. If you are aware, okay, 0 or negative 2, 1. Okay, I think let me just say you are aware, so we can just quickly cover this thing. So now we have the sigmoid function. So sigmoid function you already have seen in the logistic regression. So sigmoid function we already have seen the logistic regression. And sigmoid function says that the value will be 1 by 1 plus e to power minus x. And the graph of this one is, for the high value of negative, it will be almost 0. For x is equal to 0, it will approach to the it will approach to the 0.5. And for the high value of x, it will saturate to the 1. So this will be the graph. Value between lies between 0 to 1. And at x is equal to 0, it will be the 0.5. This is your sigmoid function. Then after that, we have another function is my tanh function. I have the next function is the tanh function. Tanh function. And as per my knowledge, the tanh function is e to power minus x minus e to power x divided by e to power minus x plus e to power. This is my tanh function. And tanh function is again a activation function, and the graph of this activation function will be like this. Value will be minus 1 to 1. Okay. Now, the next one is we have the softmax activation function. Can anybody tell me the softmax function value, guys? Can anybody tell me the softmax? Okay. Again, the softmax value is your 0 to 1. Here also, the softmax output is also 0 to 1. The only difference is the formula. The formula is e to power xi divided by summation of e to power xi. So basically it is used, like for example, you have a value like 5, 10, 20. If you pass these things to the softmax, softmax give you the values between 0 to 1 and all the sum will be 1. So 5, like for example, it's giving the 5.2, 0.1 and 0.7, like this things. For the particular value, it will be just use this formula and give you the value between 0 to 1. And summation of all these values will be 1. Okay. So this is the activation function that we have. And based on my requirement, we will use these activation functions. And before that, let me just ask you a question. So I'm just covering the few important points about the artificial neural network. We have to keep this mind. We have to keep this thing in mind. First of all, can you give me the number of trainable parameters in this architecture? Please give me the number of trainable parameters. Okay, let me check it. Yes, I think this time everybody give the right answer. 39 is the right answer, guys. Now let's understand the few points. Okay, so now the question comes that, Harish, we have so many activation functions. So when to use which activation function? So this is the main key. Okay, so let's please pay attention. So this is my input layer. This is my hidden layer 1. This is my hidden layer 2. And this is my output layer. In this one, first of all, we only use the activation function in the hidden layer or the output layer. Input layer, this is only represents the input. Activation function only used in hidden layer 1, 2, and the output layer. Used in hidden layer 1, hidden layer, hidden layers, and output layer. Next thing is, which is very, very important. In a one layer, I can use only the one activation function. Like in this hidden layer 1,
I
in
have a
this,
question here.
yes,
So this activation function, why do we need at the output layer?
sorry,
You said the activation function will be used at all the hidden layers along with the output layer, right?
correct, correct. Yes.
So, I mean, the output layer that will come from the previous hidden layers, right?
Yes. I will.
Then, I mean, why do we need?
I will explain you. Not an issue. I will explain you these things. Any other question? Okay. So I will explain you this question. So now, first thing that you have to always keep in mind, for example, if I'm talking about the hidden layer 1, I will use the same activation function. Okay. So the thing is, which is very, very important, because I mean, this is kind of an interview question they ask. So activation function will remain same, will remain same for all neurons, in a hidden layer, in a layer basically. So it's not about the hidden layer, it can be output layer also. And output layer is also keep the same activation function. So activation function remain the same. Like for example, if in this layer, this is using the ReLU, then it will also use the ReLU. This will also use the ReLU. This will also use the ReLU. If it use the sigmoid, then it use this sigmoid, then this will also use the sigmoid. This will also use the sigmoid. So the function, activation function will remain the same. A different layer can use the different activation function. So hidden layer 2, hidden layer 1 can use the different activation function. Hidden layer 2 use the different activation function. It's not like that if it is the hidden layer, so you have to use the same activation function. No, you can use the different activation function. Different layer can use different layer can use different activation function. This is the next part. So activation function is okay. This is one. And now the main thing is, I'm just giving you a point. Okay, but just keep this thing in mind. And these things we will explain later. In the hidden layer, we will use either ReLU or Leaky ReLU. Yes, we have discussed this concept. Now let me ask you this question. So I mentioned that in the hidden layer, we use only ReLU or Leaky ReLU. Anyone can explain me that why we are using the only ReLU or the Leaky ReLU in the hidden layer? Any idea?
Sir, can you repeat that hidden layer ReLU and leaky ReLU once again?
So my question is that I just mentioned the pointer. The pointer is that in the hidden layer we use the ReLU. Means that all the neurons in the hidden layers will use the ReLU or the Leaky ReLU activation function. Any idea why?
Because the value which is coming in negative, it will convert into 0, so that we can use another activation function in another layer.
No. Okay, let me explain, because this is, I mean, we have to like cover. Let me just explain you these things. Okay. Let me explain you these things. So if you see these things, the only answer is that when we are doing the back propagation, if you remember, in the back propagation, we are doing the derivative. Am I right? We are taking the derivative, right? So now we have the three formulas: y is equal to x, y is equal to 1 by 1 to power e to power minus x, and y is equal to e to power x xi divided by summation of e to power xi. So which derivative will be easy? Which derivative will be easy, guys? We have the three for function. So can you please tell me that which function derivative will be easy?
Y is equal to x.
Right? Clear? So if you use the ReLU or the leaky ReLU, this derivative will be easy, and that's the reason that we use the ReLU or the leaky ReLU in the hidden layers. Otherwise, my derivative will be more complex, and chances of error, or you can say the chances of, there is a two chance, which is the vanishing gradient and exploding gradient. So the chances of this issue is very high. We will cover this thing in the CNN architecture. So this is the one thing that you have to keep in mind. The pointer is that because we know that ReLU makes the training smoother, so that's why the thumb rule says that in the hidden layer, ReLU should be used. This is clear to you now?
Sir, these three equations are for different activation functions.
Yes.
First one is for ReLU, second one is for sigmoid, and third one is for
Softmax.
softmax. So you are saying that derivative means differentiation of this?
Yes.
So you are saying that differentiation of this is easy?
ReLU is easy. The first one is easy. The differentiation of ReLU will be easy. That's why we use the ReLU in the hidden layer.
No, differentiation of ReLU means dy by dx.
Correct.
Is equal to 1. It will be always 1, right? Since x is, if we differentiate.
No, it will not be the x, man. It will be the W1 x1 plus W2 x2 plus W3 x3, right? And then we are passing to the this one, right? This is basically, this is my ReLU, right? Y is equal to W1 x1 plus W2 x2 plus W3 x3. Right? This is my ReLU.
So
Right?
that
It will be a single line, basically a linear line. And then if I do the dv by dw1, it will be the x1. If I want to do the dv by dw2, it will be the x2. But in this case, it will be very difficult. In this case, if the equation will become like 1 by e to power minus w1 x1 plus w2 x2 plus w3 x3 dv by dy W1 will be very difficult to calculate. Or it will not be saturated, it will keep increasing and create a exploding gradient problem. Now it's clear?
yeah, better it is, right?
Right?
But
Anyone who has a doubt, please let me know.
yeah, Harish, I have a question. Okay.
Mhm.
Now, I mean, see, taking the gradient for the ReLU or the other one, okay, if it is easy, how could that be advantageous? Like what is the disadvantage with the other cases? If it is very difficult to get the derivative, but for a machine, it should not be difficult, right?
No, no. again, it make my training process lengthy, first of all. Okay. And another benefit is, like, let me tell you the things. Let me tell you the things. Okay, like, you are asking this thing, so let me explain you this concept. So now in the back propagation, basically, I'm doing the chain rule of differentiation. Correct? Correct. This is my chain rule of differentiation that we are following the back propagation. Now you tell me, so if I take the derivative of my, if I use the sigmoid here, if I use the sigmoid here, the derivative of sigmoid will become again something very complex. And then as we have the chain rule of differentiation, this derivative either exponentially increase or exponentially decrease or become zero. So when I use the sigmoid or softmax, as both derivative are very complex and they are not normalized, they are either keep increasing or decrease. So when they are keep increasing, and I'm using the multiple layers, a situation will come where my derivative, the calculating derivative will become infinite. And we call this problem as a exploding gradient problem. We call this thing as a exploding gradient. If my this calculation is become infinite, what is the problem? The problem is that when I'm calculating the d5 new, which the formula is the w5 minus learning rate, and now this derivative has become infinite. So my new weight will become infinite, and based on this new weight, if I further update the weight, and in this infinite, if I do any plus minus things, it will become infinite. And when it become infinite, then my training stops. Previous value is also infinite, next value is also infinite. So one thing is my training stops basically. So this is the problems if you use the sigmoid or softmax. And if my derivative is decreasing, so a situation will come that slowly it will vanish and reach out to the zero. And these things we call it as a vanishing gradient problem. Vanishing gradient problem. What is the problem with the vanishing gradient? What is the problem with the vanishing gradient? So when I'm calculating this w5 new is equal to w5 minus learning rate into vanishing gradient, means that my derivative, this derivative will become zero. When this becomes zero, so my equation, my weight will be w5 new is equal to w5. Means that there is no updation in the weight. And again, this process means that my training stops. So the thing that I wanted to say here is that if you use the sigmoid or softmax, the problem is that if we are using the multiple layers, the chances of vanishing gradient or exploding gradient problem is high, which stops your training process. This is the problem. Now let me know if you have, now it's clear to you or not. And this is very important to understand. Although like we call this as a thumb rule that we should use the ReLU as a in the hidden layers, but why only ReLU in the hidden layers or the leaky ReLU in the hidden layers? Because of avoid this vanishing gradient problems.
Harish, can you go up like there
Yeah.
was is if you can go up dy by dh. What is p here? What is p here?
No, I'm
dh.
just taking some layers, right?
Okay,
Remember,
okay,
like I'm
okay.
just showing some layers, like
Output from
H1
different
is
layers.
output layer, then
Okay,
P1. I'm just
okay,
showing you this concept.
okay. And then why would the gradient go infinite? Is my question. Like,
So yes. So I'm just telling you. So when you are getting these values right. So for example, when you are doing the dv by dh, this value comes as 100. Okay. Then this h is coming again 100. This this again come like for example 1000. So all this calculation you are doing it, they are exponentially increased,
okay,
right? And if you are using, because in the real time scenario, it's not like that you are using only one or two layers. Maybe we need to 10 to 15 layers or 20 layers. So just imagine that I'm using this 100 power 20, will be very huge.
yeah. See, this will happen only if the output from that neuron is high, correct? In those cases,
No, no,
your pH.
because output is also high, and also if you see these things, this calculation, right? This derivative of sigmoid is also make the value high.
Okay, 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 okay. Yeah, thank you.
Any other doubt? Tell me, guys, please don't make it with you. Just ask this doubt with me.
Yeah, can you please scroll up to the architecture diagram?
Uh-huh.
Right. So if we say that W5 is equal to W5 new is equal to W5, right? So we are saying that uh, in this architecture diagram, the weight is same for the two layers.
No. Well, I'm saying that, okay, for example, this is my W5, correct? First
Mm-hmm.
time. In the next iteration, I have to update these things. Correct, because we have to do this iterative process, right? Remember in the back propagation, we are saying that I perform the feed forward, get the output, and now I'm going back to update the weight, right? So this thing we explained in the last lecture.
Yeah, if we take first layer as H1, then W1, X1, W2, X2 plus B1, right?
Yes. So like we are calculating we have some, like for example W1, W2, W3 is here, and then we are doing some calculation. This output is coming. Then we have some other weight. Then output is coming. Then this thing, right? And then after that, I'm going calculating the output, and then after the calculating this output, I'm going in the backward direction and updating the weight. Like for example, I want to update this D1. So this output is depend on output, this W1, this output is depends on this H1, and this H1 is depends on this P1, and this P1 is depend on the W1. Am I right? So we have to go in the backward direction, and when we are doing the derivative, so derivative will be also in the backward direction. This is what we have seen in the back propagation. And now when we are doing these things in the backward direction, the problem is that, like for example, in the one iteration, in the initialization part, W1 is equal to 5, for example. Now, after getting this output and I'm going in the backward direction, W1 new is coming as a 6, for example. And now, again, the next iteration, so corresponding to the 6, I will calculate the output again and then again update the weight. But this time, vanishing gradient issue comes, and my W1 again, new 1 is again 6. Means that now my weights are not updating. And when my weights are not updating, it means that my process gets stopped. Because what is my training process? My training process means that throughout the iteration, my weights are getting updated and reaching to the optimal values. Yes or no?
So this W1 is equal to 5 and W1 new is equal to 6 is the same W1. This is the first
Yeah.
layer.
Yes, same W. Because this is my training process. In the training process, I have to keep updating this W1 in the each iteration to find the optimal values. Let me just show you this graph. I think this things is uh, maybe sir will explain in the logistic regression. So the thing is, this is the graph between loss function and W. Okay. And the graph looks like, for example, this one. So for this point, my weight are this one. This is my some W1. Okay. Now I want to update my weight in such a way that I can reach this point. So I will take a one iteration or one back propagation, and after the back propagation, my loss function come to this point. Corresponding to this point, this is my W1 new. And now for corresponding to this W1 new, again I take the output and check the loss, and now again the loss is reduced, and now I will update the things. So now this is my W1 new one, and then I will again check for the W1 new one. Again I will check the loss, it will this one, and again I will update the things. This will be W1 new 2, and now I will come to my minimum point, which corresponding to this minimum point, my weight is W new 3. And this is my requirement. I want to find the optimized weight corresponding to loss is minimum. But if my weight is getting same, so it means that my loss is getting stuck here. Am I right? If my W1 new is equal to W1, so my loss is stuck here, right?
Yes.
So when my loss is get stuck here, we are not able to reach the minimum point. Or you can say that my training stops. Makes sense, right?
Yes.
So I want to reach this point. I want to reach this point. But every time my weight is coming same, so my loss is getting stuck here. We will not be able to find out to this minimum point.
Yeah, so this point is where the slope is 0 or there is a minimum error.
Minimum error basically. Yes, slope is 0, or you can say the minimum error.
So this point is where the actual minus predicted is minimum, right?
Yes, the difference between actual and minimum is lowest.
And we are trying to predict the weight for that point where the difference between actual minus predicted is lowest, right?
Yes, we have to keep updating this weight. We have to keep updating this weight so that when I check the output, this output will be close to the my actual output. This predicted output will be close to the actual output.
And predicted output is the last one, the last neuron, the rightmost neuron.
Yes. Predicted output is coming from the last rightmost neuron.
Okay.
Any other doubt?
Yes, and what makes this move to the next point? We said it gets stuck in W1 new, and what makes this move to the next point?
Can you speak loudly? I mean, I'm not able to hear you properly. Is it for me or others can also not able to hear him properly? Hello.
Yep, I'm sorry. So we are saying that, can you hear me?
Can you speak loudly? I mean, I don't know whether it's an issue only for me, guys. You can hear him, Shiva, clearly.
Okay. Now audible now?
Yes.
Okay. So you're saying that like we are moving from W1 to W1 new and then to W1 new, and then like if the values are same, it gets stuck at one point
Yes.
from the graph. Okay.
Yes.
But it should move to the global minimum to achieve the optimized value of it.
Yes.
So what is it, the learning rate that makes it move to the next point, or is it some other thing which makes
No,
it
no.
a global
See,
minimum? Which
if
moves to
the
global-
learning rate, whatever the learning rate is there, if I multiply with a 0, it will make it. Let me tell you the things. You can hear me, right? Hello.
Yeah. Yeah.
Yeah. So what I'm saying is,
Yes.
you are saying that, Harish, what will be the effect of the learning rate? Correct? This is your question is, or that how then because
Yeah.
we have the learning rate also, so this should also come in the picture. Let me tell you the things. So when W1 new, I am going to calculate, and the formula is W1 minus learning rate into derivative of loss function with respect to W1, and then when this value will become 0, 0 into learning rate will be 0, and output will W new is equal to W1. Doesn't matter whatever the learning rate that I have, when it multiply with a 0, it will make it 0. Make sense? Shiva, now it makes sense to you?
Yeah. Yeah.
Yeah. Okay, please ask your question, guys, because this concept is important and very interesting as well, right? If you see these things, it's a lot of things are revolving now because these are the foundation things about my artificial neural network, right? And if you don't clarify your doubt here, then maybe when we just start writing the demo part, you may face some error. That's the issue. Clear? Any doubt? Please let me know. Okay, I'm assuming no doubt. So this is the issue that we should be aware. And now the next part is hidden layer is complete. So in the hidden layer, we use the ReLU or Leaky ReLU. So one thing we have clarified that in the hidden layer, we use the ReLU oblique Leaky ReLU. Now in the output layer, so for output layer, mainly like if you have the regression problems, then you don't need anything because already it is coming as a line. But the main problems comes that as a classification. So in the classification, we have the two type of classification. One is the binary classification and another is the multi-class classification. Can you please tell me the difference between binary classification and multi-class classification?
Binary means two, multi means more than two.
Yes, yes. So basically, like, I mean, it's simple. I mean, binary classification is then when you are doing when you have the two class, but multi-class is when you have to predict the multiple class, when you have to predict the multiple class, and in that scenario we have to predict from this class. So when we have this binary class where the class is either 0 or 1, we use the sigmoid function, because sigmoid function gives me the output which can be treated as a probability of a class. Clear? And now in the multi-class classification, we use the softmax, because for the softmax, if you remember that softmax give me the value like 0.1, 0.2 and 0.7, means that if you have the three class, softmax gives me the probability of that all these three class, give me the probability of this three class, and the summation will be 0. Sorry, summation will be 1. Summation will be 1. So when you have the binary class, we will use the sigmoid as a activation function in the output layer. When we have the multi-class classification problems, then we will use the softmax as a activation function in the output layer. This thing is clear to you? Any doubt here?
Last step, what is it? Summation is equal to 1.
Means
Is
that the sum of the probability will be 1. If you see these things, 0.1 plus 0.2 plus 0.3, it will be 1.
Got it.
Okay. So this is our next point. So these are the important points. Please keep these things in your mind, because we have covered a lot of things new today. And now let's see some terminology that is being used in the deep learning especially. One thing is that we use it epoch. Okay, we use this term especially in the deep learning. You haven't heard these things in the machine learning or the NLP. So we heard these things in the deep learning only. So what is this epoch? One epoch means covering the entire data one time. Data once. So the thing is, as I mentioned, that deep learning is used for the complex problems, like for example, image classification. So what the thing is, that, for example, I have 600 images. I have the 600 images of cat and dog, and now I want to build a machine learning model to learn from these images and perform a classification. So the thing is that if my model go through this 600 image one time, it is not sufficient for my model to learn in a single iteration or a single epoch. We have to go through because it's a complex problems to perform the image classification. If you remember your school days or the college, means if you remember your childhood days, when your parents told you that, hey, this is apple, this is banana, this is cat, so definitely at that time also we were not able to understand by a single instruction. I can remember that. I don't know what about you guys, but it's a common pattern that, like, if somebody tell you that, hey, this is your apple, this is banana, this is cat, and definitely in a single instruction we were not able to understand it properly, that what is apple, what is banana, what is cat. Then if you remember that we saw the same thing in our class, then as a homework we are also getting the same thing, that please remember this is apple, this is banana, this is cat. We do these things multiple times, only then my brain slowly extract the features, and then after that my brain comes in a state where it can perform the classification easily. Otherwise, if you see these things, your kid is also giving the different, is not able to give the difference between apple and orange. This is generally case, right? So they are not able to differentiate between apple and orange, right? So these are the few examples, like, I mean, this is real time examples, and same thing is applicable in the deep learning also. One single iteration of your data is not sufficient, so I have to go through this training data multiple times, and then I have to run the multiple epochs. For example, if I'm saying that I run the model for 10 epochs, it means that we will cover the data, training data, not the data, it's training data 10 times. 10 times. Because problem is not that much easy. We have to go through these problems. We have to go through this training data multiple times to understand the features of my multiple class. This part is clear to you?
Sorry, Harish, like 10 epochs on the same, like one
Same
epoch on
data.
the same data.
Yes, yes.
Okay, same data will use it for the 10
10
times.
times. Yes, yes. Why we are doing these things? Because our problem is complex, and in the single iteration of my entire data, it is not possible to learn from the data and perform the classification for the model.
Okay, thank you.
Okay. Any other doubt? Please let me know.
But Harish, this back propagation that we normally do, right? Okay. So
Mm-hmm.
that can be based on the case-based propagation or the batch-based propagation, right? I mean, when I
No,
say
no.
case-based,
Can you speak loudly?
yeah, is it audible now?
Yes.
Okay. So when we do this back propagation for adjusting the weights and the bias values, okay.
Mm-hmm.
So we can do that once we have covered one of the observation through the network. I mean, through the hidden layers. Okay, and then you do calculate the errors and do the back propagation to adjust the weights and
Correct.
bias. Right.
Correct. Correct.
Okay. The next approach is you carry that to the entire batch of observations. Okay, and then take the average of the error, then adjust the
We
weights
will
and the error.
discuss
I
this
mean
thing.
the bias value.
Yes, we will also
No, no, no.
discuss
My
this.
question is, no,
Uh-huh.
no, my question is, okay. So in the first case where we are adjusting the values after one case of execution, are we
Mm-hmm.
not calling that an epoch?
No, 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 no. One epoch means that completing my one entire training batch. One epoch means not the like one training sample. One epoch means that, like, for example, as I give you this example, that I have 600 images. Okay, so my one epoch get completed once I pass through my all 600 images once. Clear now?
I mean, so what I meant to say is, see, epoch does that depend on the covering all the data points or the images or some, I mean, data points in the entire data set,
Yes,
or
entire
is it
data set.
do a forward propagation and then do a backward propagation to adjust the bias and the
No,
values?
this
So
is
that
the
iteration is called an epoch, right?
no. Okay, let me clarify these things. Okay, let me clarify these things, guys. Please pay attention. Let me clarify these things. I have 10 images. Okay, I have the 10 images. I will take the one image, perform the feed forward, perform the feed forward, perform the back propagation, and update the weight. Correct? Correct? Then after that, after updating this weight, I will pass my second image. Then perform the again feed forward, back propagation, then update the weight. Then with this new updated weight, I will test this weight in the third image, and this process will go on till the 10th image. And this when I will complete this 10th image, my one epoch get completed. Now let me know if you have any doubt now.
No, got it.
Okay. Please ask your doubts. If you have any other doubt, please ask your doubts.
Second image of feed forward, back propagation, and what is that last one? Update the weight or
Yes, update the weights.
okay.
Okay, any doubt here? And in the real-time scenario, we always mention this thing like I'm running the 20 pokes, I'm running the 30 pokes, 50 pokes, 100 pokes, like these things. Okay, so when I'm saying the 20 pokes, so you should create a image that yes, the meaning of the epoch is that we are going through the entire sample 20 times. Then in this concept, in this deep learning, we are taking a one more concept of the batch. Okay, so maybe in your traditional machine learning, you haven't heard this concept of batches, but in the deep learning, we mostly use the batch because without batch, it's not possible to train it. It will take a lot of time. So as I mentioned that, for example, I have the 600 images. In the real times, they are thousands of the images, like 70,000, 80,000. I'm just taking a very simple case that I have the 600 images. I'm using the two approach. One approach is pick the one image, perform the feed forward, perform the back propagation, update the weight, and then pass the second image. Same feed forward, back propagation, and update the weight. These things I'm doing the 600 times. Another approach is that I will create the batch of the 10 images. I create a bundle of the 10 images. I'm calling it as a bundle, guys, for the simple term. I'm creating the bundle of this 10 images. Again, 10 images, create a bundle. So like these things, I have the 60 bundles. I will take a one bundle or the batch. I will take this entire 10 images bundle, pass to my perform the feed forward, perform the back propagation, perform the update the weight. And then again, next 10 bundle, next bundle, 10 images, next 10 images. And like these things, I will have to perform the 60 times iteration. Can you please tell me that which approach is good? Or let's take the realistic example, make it as a 60,000 images. Maybe now you are not able to correlate. So when I have 60,000 images, so this iteration will be 60,000 times, and this iteration will be 6,000 times. Can you please tell me that which approach is good? And if you found any limitation, you can tell me the limitation also. Just share your thoughts, guys, on this one.
I mean, the time it takes to try the model will be more in the case-based approach.
Yeah, but then even if we are doing it in batches, it has to process all the 10 image in the batch, correct?
The back propagation would be
Yes.
once for 10 images.
Yes.
Okay, okay.
Means
Only
feed forward
will
will
be
be
once.
10, but
Okay.
updating won't be once.
Okay, feed forward will be 10 times, and see backward propagation would also be 10 times, and then only update would be once, is what you're saying.
Means back propagation is nothing but updating the weight,
Okay,
right?
bits also. Okay.
Huh,
Okay.
means that I'm just first pass the 10 images, calculate their 10 outputs, and then update the weight.
Okay.
So tell me, guys, what's your thoughts basically? I'm not expecting any wrong or right answer. We are not discussing any wrong or right answer here. I'm just discussing the things that what is the good approach, what is the benefit of this first approach, what is the limitation of the first approach, similarly what is the benefit of the second approach, and what is the limitation of the second approach. I mean, just this normal discussion. I just want to see your approach, that how you are thinking in this in the each scenario. So what kind of a benefit that you found in the approach one? This is my approach one. Or any benefit or the limitation, anything that you found, please let me know.
See, it will be fine tuned, and then since we are doing it for every sample,
Mm-hmm.
we we may not skip uh, um, granularity. Like in the other case,
Mm-hmm.
since we are doing update only after 10 with 10 sample, if there
Mm-hmm.
is a variation within those 10 sample, I think we may miss it.
Okay, that's good. A good analysis. Okay. Okay, so you are saying that approach one is definitely better than the approach two because uh, we may miss the granularity, or you can say that we may miss the similar small things, right? This
Yes,
is what
yes,
you are
yes.
trying to
Correct,
say.
correct.
Okay.
Some very minor things.
Okay. And any limitation you found in the approach one?
Yeah, process time to complete or converge.
Yeah, time. Okay. So, but definitely the time taken will be high because 60,000 iteration will be very high. And one more thing I want to mention here is this 60,000 will be in the one epoch. Am I right?
Yes.
Right?
Okay. Yeah.
One epoch means 60,000 iteration. And then we have to do such kind of a 10 to 15 epochs. So you can imagine that if I just take a very simple 10 epoch, 10 into 60,000, which will be 6 lakh, right? So the weight updation will be 6 lakhs time, right? In the approach one. And in the approach two, it will be only 6,000 into 10, which is the 60,000. See the difference of 6 lakhs iteration and 60,000 iteration. Difference is like very huge. Correct. Now question comes to your point that Harish, if we do the less iteration, if I do the less iteration, then we may miss the small things. I'm totally agree with your point. But 60,000 iteration is also sufficient to get the all the information. And another approach is which is like let's discuss let's discuss this thing. Okay, please pay attention. I request each and everyone to please pay attention, because if you got this concept, then you can easily understand this concept, and also you can give the answer in the interview, because this is very common things generally we ask as a in my company also, I take the interview, and we also focus on this type of questions to understand whether you have the real knowledge of the deep learning or not. So the problem is that if I do these things one by one, for example, my model get the cat image as a input. My model get the cat image as a input. My model adjusts the weight and update the weight in the one iteration. First image was the cat image. My model see these things and then update the weight according to learn from the cat image. Next image is dog image, which is totally different from the cat image. The features will be different. Cat has a different features, dog has a different features. Then again, my model has to adjust the weight because this time output is totally different. Again, my model has to do lot of changes in self and adjust the feature as per the dog image. Then again cat image, then again has to change a lot of things. So if I do this single iteration, the variation of changes will be very high, and also, like, you need a very good resources to compute these calculations. And you are also aware that to perform the this deep learning task, we use the GPUs, right? So it's not like that your model building is your main objective. To create a optimized model is your main objective. If you are building a model, if you are building a model in 3 hours, and same model can be built in half an hour, and both are giving the same accuracy, so definitely half an hour model is optimized model, because to train it we need only 30 minutes, but for your model it took the 3 hours. And you know that when in the project time, in the real time, when a client gives you the data and ask you that, okay, give me a image classification model. For example, they want to let me tell you my real time example, that when I worked in my company, so we got a request to build a model to identify the real checkbook, means check in the banking part, or the fake check, because it may be possible that they may get the fake check as well. So they want a machine learning, a deep learning model to just perform the classification between the real check and the fake check. In that scenario, when we got this problem, so company will check that how much, means how much amount that we have to charge for these things, right? And this is where your experience comes in the picture, because nobody knows that how much hours it will take to perform this model. So they will come to the data scientist, they will come to you that, hey, please tell me the estimation time of training. What will be the resources, what resources you are going to use, which GPU machine you are going to use, and how much training time it will take. And based on these things, they will charge the cost, means they will just set up a cost, that this will be my cost for giving you this model, tentative cost. So for these things, you have to just know that what will be your training times, right? You have to optimize your models. So in that scenario, a batch processing helps you. If you do the single by single, one by one, it will work. It's not like it will not work, it will work, but your model will be more unstable, and time taken will be also very high. So this part is clear to you, why it is unstable and why the time taken is high in the first approach. Tell me each and everyone, guys, please let me know, because if you got this concept, then definitely your foundation will be good, and it will be easy to see these things in the coding part.
Yeah, but Harish, one more thing. So in the other approach two, your
Mhm.
first 10 images can be cat and the next 10 images can be all dogs. So in that case also, the weights would be updated.
Yes.
Uh,
So, but we always shuffle the images. It's
Okay.
not like that we are passing the 10, 10 cat in one batch, 10 dog in a one batch. No, we mix the images and create the bundle, then pass it.
Okay. Okay. That is right. In the approach one, see why is it a problem that when you move from cat to dog,
Mhm.
see you have to anyway update the weights now
Yes,
because you had a image of dog. Instead of changing the weight by 0.1, you are changing the weight by say 10, correct? Some
yes,
higher scale.
yes.
Why is it a problem? Machine anyway has to do that job, so
No, no,
it should.
yeah, no, I'm not saying that. See, problem is the calculation. Calculation will be high, right?
Okay.
Range will
Okay.
be high, making as, see, I know the problem, machine can do these things. We have the two scenario. Machine can do these things in the 1 hour, machine can do this thing in the 2 hours.
Mhm.
We have to think also this way also, right?
Oh, okay. So I still don't get it that okay, why would it take machine more time? See, okay, I understand that
So fluctuation
weights
will
and
be, no, no, I'm
uh,
not, I'm saying that, I'm not saying that machine, see, is again a calculation. The fluctuation will be high.
yes, yes, correct. And then would that lead to higher compute time?
No,
Is
no, no.
uh,
Your model will not be stable.
okay.
Again,
So
for
to
example,
converse into a model,
let me tell you one more thing in a simple way. You see the cat image, correct?
Uh-huh.
You adjust the weight,
Mhm.
correct?
Yes.
Now you got the dog image.
Uh-huh.
Suddenly your loss will be very high,
Correct.
right?
Yes. Yeah.
You are going in a direction to reducing the loss, but your loss
You will
is
get
very high,
high.
right?
Correct.
Now
Correct.
you adjust the weight according
Based
to
on
the
that.
dog.
Uh, uh,
Then again cat image come, again your loss is very jump high. So
okay.
sometimes loss is going very down, then again very high, again low, very high. So this kind of a fluctuation is, let me just show you these things.
No,
So
I got that, but then that would mean that the model will never converge in this case
I mean,
if you
it
have
will face
alternate
problem.
images.
Yes, it will face problems. So your model is like behaving like these things,
Mm-hmm.
right?
Yeah, yes, yes.
You getting my point?
Correct, correct.
So although it is down, it is getting down to
Converge.
the minimum point,
Uh,
but it is not that smooth process.
okay.
Makes
Yeah,
sense,
yeah.
right?
Yes, yes,
So
yes. This
you
makes sense.
can see, like for example, let me just tell you one more simple example that you want on the top of this hill and you want to come here. Okay, so there the one way is that you are consistently getting down, and another way is also that you are taking the 3 step down and 1 step up.
Mm,
This is also possible,
mm.
right? You are taking the 3 step down, and after the 3 steps, you are taking the 1 step up, then 3 step down, then 1 step up, then 3 step down, 1 step up. Also, in this way, also you will reach the minimum point or you will reach the base. But is it the right way? No,
Yeah, yeah, okay. I got your point. Yeah,
right?
thank you.
This is the problem. Any other doubt? Tell me doubt. Tell me, guys. Okay, I'm assuming no doubt. So that's why we use the concept of the batches. We will just shuffle the images. We first shuffle the images and create a batch and pass this batch to the training process. Pass this batch to the training process. Okay, so this is the
so
benefit of the batch. And in this,
when we
while
create this batch,
Mhm.
there is one question. When we create this batch, right, so do we also make sure there is at least one data point from each category, like the dog,
We will just do
cat,
the
and
shuffling. We first do the shuffling, and when we are doing this shuffling, so it's a very less chance that we have the image of the all the image of the single data points. Or if you want to verify, you can also verify. But when you are doing the shuffling, so it's very less chance that all the data points or all the images of a single category.
It's a random sampling. I mean,
Yeah, random sampling. We're
to
doing the random.
maximize the
Yes, random sampling. We're doing the random shuffling, basically, not the sampling. We do the random shuffling and then create the batches. Any doubt here? Okay.
Sir, can you explain this when we do it in batch and when we do it alone, right? There are two approaches. So when we do it in batch, how the weights are updated only once, and when we are doing it single by single, why the weights are updated in every iteration? And on the back you were explaining it, right? When the weights are updated, yes, here it's in the approach too. Like how it is.
I passes the 10 images in a bundle, right?
Mm-hmm.
I got the 10 output, correct?
Mm-hmm.
Corresponding to the 10 output, we have the 10 actual values. This will give me the loss. I will use the cumulative loss and then update the weight.
10 output means
10 image I pass. My model performs some 10 output, some prediction, right? When I'm passing the 10 image, I will get the 10 output. My model is doing some prediction. Hello?
yeah. So your model is doing the prediction whether it is a dog or a cat, right? 10 images
Correct.
means
10 classification will be there. Like maybe first image is cat, another is dog, third is
yes,
cat, then dog, like this thing. Correct?
yes.
Corresponding to this 10 outputs, I will have their actuals also. Maybe my model says that hey, it's a dog, but actually it's a cat.
Correct.
Correct.
Yes.
So in that scenario, my model has to calculate the loss.
Yes.
So I will calculate the loss of entire batch, not the single image.
Okay.
And then once this loss is calculated, I will perform the back propagation.
So when we are doing the numeric regression, right, linear regression or logistic regression, then the loss is numbers. But when we are doing the classification, so what the loss value will be, for example, like.
Okay, I got your point. Let me tell you the things. Okay, I will take these things also in a more deeper way. When I'm saying that this is dog, this is cat. Okay, for example, this picture, I'm not good in the drawing, guys.
Yeah, that is okay.
Okay, this picture is the dog picture. Okay, for example. Okay.
Mm-hmm.
So I'm calling it as a 1, 0. 1 is means dog and cat is 0, right? Means that this picture is belong to dog. This is how we do the one hot encoding, correct?
Correct.
So I pass this value that hey, actual is my 1, 0. But when I pass these things to my model says that because we are passing the sigmoid function, my model says that hey, 0.7 probability is for the dog and 0.3 probability is for the cat. Okay.
Mhm.
This is my model output. This is my model output. This is my actual output. And now I will, can you please tell me that for the classification problem, which categorical, oh, sorry, which loss function we use? Cross entropy loss, right? This is the loss function which we use to calculate the loss for the categorical problems. And formula is minus of y1 log p1 plus 1 minus y1 log 1 minus p1. Or you can say that y2 and p2. Or you can say that y1 log p1 plus y2 log p2. Both are same. Now, my y1 is 1. My actual value is 1. but the predicted value is 0.7, so log 0.7. My y2 is 0 and my predicted value is 0.3. So this 0 into 0.3 will become 0 and this will become minus of log 0.7. And what will be the minus of log 0.7? Log of 0.7, what will be the value of log of 0.7? Let's do it right now. Log of 0.7. This is the minus 1.54. So I will get is minus of minus 0.154. So loss is my 0.154. This is for the one image. Similarly, second image will also give the loss. Third image also we have some loss. Definitely it may be high or low, but we have some loss. And then after that, once we will get this 10 loss, means that corresponding to the 10 images, I will add this loss and perform the back propagation. Now it's clear to you?
Yes, can you scroll up a bit? Just like I want to see this image, right? Dog means that the actual value, we are saying that we are providing the image of the dog to the model, right? So 1
Yes,
is dog and 0 is cat.
correct.
Same way is if we provide the image of cat, then
It will be 0,1. For the
0,
cat, it will be 0,1.
right.
Right? Means 0 probability for the cat and 100 probability for the 0 probability for the dog and 100 probability for the cat. This is my actual value,
Yes,
right?
and
But
the
my model says that because model is not 100%, right? Might be model says that 0.1 and 9.9. I'm 90% sure that it is cat and 10% sure that it is dog. Again, we have to calculate the loss because this value ideally should be close to very close to 0 and the higher value 0.9 should be very close to 1. So this is my training basically.
yes, and so we will do it for 10 images for a particular batch. We
A
will
particular
calculate
batch, the 10 images, then add all the losses and then perform the back propagation.
got it. Yeah.
If I do it one by one, you can imagine that how much calculation we have to do and it will be very time consuming process.